Welcome to chemistry classes. In this video, we are going to discuss about macromolecules. Macromolecules. Here, consider this example: ice, phosphorus, and sulfur. Ice, phosphorus, sulfur. This type of substance, there is weak force of attraction between the molecules. There is weak force of attraction between the molecules in this substance: ice, phosphorus, sulfur. That's why this type of substance showing less melting and boiling point, because weak force of attraction between the molecules and it need less energy to break this bond. That's why this type of substance showing less melting and boiling point. But when you consider diamond, graphite, silicon oxide, this type of substance showing very high melting and boiling point. Diamond, silicon oxide, graphite, this type of substance showing very high melting and boiling point because strong force of attraction between the atoms. In this substance, there is very strong force of attraction between the atoms. That's why it need very high temperature, very high energy to break this bond, and they showing very high melting and boiling point. Okay, and this type of substances are example for macromolecules. Macromolecules: diamond, graphite, silicon oxide. Okay, this type of substance are macromolecules, and these are giant molecular solid. This is also called giant molecular solid. Clear? Okay, so let us study here diamond. Diamond. You can see here diamond. This is the structure of diamond. Diamond, which consists of 4 strong covalent bonds. In diamond, one carbon atom make 4 strong covalent bond. That's why diamond is the hardest material in the world. Diamond is the hardest material because it consists of 4 strong covalent bond. Diamond, there is no free moving ions or electrons. In diamond, there is no free moving ions or electrons. That's why diamond is insulator. Diamond is insulator because there is no free moving ions or electrons. Diamond is hardest material because it consists of 4 strong covalent bond. In diamond, one carbon atom make 4 strong covalent bond. Okay. Here different uses of diamond. Different uses of diamond. Diamond used in jewelry. This is a very important use of diamond. Diamond used in jewelry. Also, we discussed here diamond is the hardest material. That's why diamond used to cut glass, hard materials such as rock, stone, etc. Okay. Also, diamond used in drilling machine. Okay. Diamond used to drill materials because it is very hard substance. Clear? So here we discuss some points related to diamond. Diamond, it is giant molecular structure. It is very hard, and it is very hard because it consists of 4 strong covalent bond. Diamond, it is insulator because there is no free moving ions or electrons. Okay, and some uses of diamond: diamond used in jewelry, also diamond used in drilling machine, also it used to cut glass, also used to cut hard materials such as stone, rock, etc. And this is the structure of diamond. This is the structure of diamond. In diamond, one carbon atom make 4 strong covalent bond with adjacent carbon atom. Okay, and here this type of structure is called tetrahedral structure. Tetrahedral structure. Okay, and in diamond there is no delocalized electron, there is no free moving electron. That's why it is insulated. Clear? So these are the substance, these are the example for simple molecules. Simple molecules mean the molecules which contain weak force of attraction. Weak force of attraction between molecules. That's why this type of substance showing low melting and boiling point. Example for simple molecules: sulfur, phosphorus, ice, etc. Okay, and here we discuss giant molecular solid. Example for giant molecular solid: diamond, silicon oxide, graphite, etc. Here graphite and diamond are allotropes. Graphite and diamond are allotropes. Allotropes mean they are one element but exist in different form. One element exists in different form. Okay, chemically they are same. Chemically they are carbon, but they have different physical properties. Such type of different form of same element are called allotropes. Okay, graphite and diamond are allotropes. Now we learned diamond. Clear? Okay, next one we have to discuss here graphite. Graphite. Already we discussed graphite and diamond are allotropes of carbon. Graphite and diamond are allotropes of carbon. See here, this is the structure of graphite. In graphite, one carbon atom make three covalent bond with adjacent carbon atom. In graphite, one carbon atom, each carbon atom make three strong covalent bond with adjacent carbon atom. Also see here graphite, which consists of layers. It consists of layers, or it consists of sheet-like structure. Each layers are bonded together by weak bond. Okay, and here graphite, it is good conductor of electricity. Graphite, which consists of delocalized electron. I told you in graphite, one carbon atom make three strong covalent bond. Fourth valence electron, you know the valency of carbon 4. Valency of carbon 4. Okay, so here three valence electrons make three strong covalent bond. The fourth valence electron free and it can delocalize and it helps to pass electricity in graphite. Okay, and the graphite, it is slippery. Also it conduct electricity. So look here, these are the points we discussed here. Graphite, it is one allotrope of carbon. In graphite, each carbon atom make three covalent bond. Okay, and it consists of sheet-like structure. Each sheets are bonded together by weak bond. It is soft, slippery. Also layers can slide each other. In graphite, there are layers. These layers can slide each other. That's why graphite used as lubricant. Graphite used as lubricant. Also graphite used in pencil lead. Graphite used in pencil lead. Also it used as lubricant because graphite consists of layers and these layers can slide each other. That's why. Okay. Also another use of graphite used as electrode. In electrolysis, graphite used as electrode because graphite, it is inert. Graphite, it is inert, unreactive. Okay, graphite, it is unreactive or inert. Also it is good conductor of electricity. That's why graphite used as electrode. Clear? So here we discuss graphite, which consists of sheet-like structure. Each sheets are bonded together by weak bond and these sheets can slide each other. That's why it used as lubricant and pencil lead. And here in graphite, there are three covalent bonds, strong covalent bond. Fourth valence electrons can delocalize and it conduct electricity. That's why graphite used as electrode. Okay. And here graphite is one of the allotrope of carbon. Clear? Okay, next one we have to discuss here silicon oxide. Silicon oxide. Here we will write it silicon 4 oxide because the valency of silicon 4. That's why we can write silicon 4 oxide. Actually it is silicon oxide. Silicon oxide formula SiO2. The formula of silicon oxide SiO2. See here the valency of silicon 4, valency of oxygen 2. But the formula of silicon oxide SiO2, because look here Si4, the valency of silicon 4, Si plus 4, oxygen minus 2. So we can cross multiply this. So here it will be 2, here it will be 4. After simplify this with a common number 2 by 2, 4 by 2. So it will be Si1O2. So the formula of silicon oxide will be SiO2. Or you can say in silicon oxide, this is the structure of silicon oxide. In silicon oxide, one silicon atom make 4 strong covalent bond with adjacent oxygen atom. One silicon atom make 4 strong covalent bond with 4 different oxygen atom. Similarly, one oxygen atom make 2 strong covalent bond with adjacent silicon atom. One oxygen atom make 2 covalent bond with the silicon. Okay, see here, one oxygen bond with the 2 silicon. One silicon bonded with the 4 different oxygen. Okay, that's mean the valency of silicon 4, valency of oxygen is 2. Clear? That's why the formula of silicon oxide is SiO2. We can draw the structure of silicon oxide simply. We can draw like this: one silicon atom with 4 different oxygen. Actually, it is 3-dimensional network structure. This structure will continue over here. This is 3-dimensional network structure like this. Okay, but it is tetrahedral structure like diamond. We discussed diamond. In diamond, one carbon atom make 4 strong covalent bond with adjacent carbon atom. Similarly here, one silicon make 4 strong covalent bond with adjacent 4 oxygen atom. Okay. And here next one we have to discuss here similarities between diamond and silicon oxide. Okay, we already learned silicon oxide and diamond. So what are the what are the similarities between diamond and silicon oxide? One similarity we can say their structure. Both diamond and silicon oxide, they have tetrahedral structure. Both diamond and silicon oxide make 4 strong covalent bond. Okay. And both diamond and silicon oxide, they have very high melting and boiling point. Very high melting and boiling point. Diamond, its melting point 3550 degrees Celsius. Okay, diamond, its melting point 3550 degrees Celsius. But graphite, its melting point around 1710 degrees Celsius. Okay, so generally we can say both diamond and silicon oxide, they have very high melting and boiling point. Both diamond and silicon oxide, they are shiny. They make 4 strong covalent bond. They make four strong covalent bond. Both diamond and silicon oxide, they are insulated. They do not pass electricity because there is no free moving ions or delocalized electron. So both diamond and silicon oxide, they are insulated. They are shiny. They have high melting and boiling point. They have tetrahedral structure. Okay. So these are the similarities between diamond and silicon oxide. Clear? Next one we have to understand here difference between what are the difference? We discussed there are similarities in diamond and silicon oxide. So what is the difference in diamond and silicon oxide? You know, diamond and graphite, which consist of only carbon atom. So they are element. Diamond and graphite, they are element. But silicon oxide means there is silicon and oxygen joined by covalent bond. So it is compound. So silicon oxide, it is compound. Diamond, it is element. So this is the difference. So remember, graphite and diamond element, silicon oxide compound. Clear? Next one we have to understand here different uses of silica, different uses of silicon oxide. Silicon oxide used in sandpaper because silica, it is very hard and it can make scratch on other material. That's why silica used in sandpaper. Okay. Silica also used to make glass and lens because it is very hard and it can pass light. Okay, light will pass through silica. That's why silica used to make glass and lens. Also silica used to make bricks for lining furnace. Silica used to make bricks. This bricks used in refractory furnace. Okay, extractory furnace. Okay, you know different type of furnace. The inner part of furnace lined with bricks. This bricks should have high melting and boiling point. Okay, so here silica used to make such type of bricks because silica has very high melting and boiling point. Clear? And also remember here, naturally occurring silica occurred naturally in the form of quartz. Okay. Also sand is the major source of silica. Sand is the major source of silica and silica naturally obtained in the form of quartz. Clear? So these are the different points we have to discuss here. Each silicon atom making 4 strong covalent bond with 4 oxygen atom. Each oxygen atom make covalent bond with adjacent 2 adjacent silicon atom. Okay, that's why the formula of silicon oxide SiO2. Okay, and here similarities between diamond and silicon oxide, they have tetrahedral structure, they have high melting and boiling point, they are shiny and insulator. Clear? And here difference between diamond and silicon oxide. Diamond, it is element, only carbon atom. Silicon oxide, it is compound because silicon and oxygen, different type of atoms chemically joined together. Clear? And different uses of silica. Here silica used in sandpaper because it is very hard and it can make scratch on other material. Silica used to make glass and lens because it is very hard and light can pass through silica. Okay, and silica used to make bricks for lining furnace because silica has very high melting and boiling point. Okay, next one we have to discuss here bonding in metals. Bonding in metals. See here this table. Here one table given. See here this information. Here different type of structure and here example and their boiling point or melting point. Here first one, simple molecules. Molecular solid. Molecular solid we discussed sulfur, phosphorus, ice. This type of molecular solid, they have weak force of attraction between molecules. Okay, here different example here, carbon dioxide, water, water mean ice. Okay, these are example for simple molecules. Simple molecules. Okay, and here the melting point of carbon dioxide minus 56, water it is 0 degrees Celsius. Similarly here giant ionic structure. Giant ionic structure mean ionic compounds. Ionic compounds, example for ionic compounds, sodium chloride, magnesium oxide. They have strong force of attraction between sodium and chlorine, Na plus and Cl minus. It is electrostatic force of attraction. Okay, and they have high melting and boiling point, 801. In case of sodium chloride, 801. Magnesium oxide, 2852. And see here, giant covalent structure, graphite, diamond, silicon oxide. These are giant covalent molecules, giant covalent structure or macromolecules. Okay, so here diamond, silica, diamond 3550 degrees Celsius, silica 1610 degrees Celsius. Okay, strong force of attraction. So here we learned already simple molecules, giant ionic structure or ionic compounds, giant covalent or macromolecules already we discussed. Okay, also here different example and their melting and boiling point. Similarly here we have metals, iron and copper. Iron and copper, iron its melting point 1535, iron, copper 1083. So look here, after observing this table, what you can expect here? Here already we discussed simple molecules, giant ionic, giant covalent. Okay, they have different melting and boiling point based on the force of attraction. So here metals like iron and copper, they have high melting and boiling point. Here we have to study now metals, bonding in metals. Okay, so here we will consider metal. Okay, metal, they have high melting and boiling point just like macromolecules and ionic compounds, not like simple molecules. Simple molecules, they have weak force of attraction. Weak force of attraction, that's why less melting and boiling point. Here metal shows very high melting and boiling point like ionic compounds and macromolecules. They have strong force of attraction and a high melting and boiling point. So we can say here, we can expect here metals which consist of giant structure and very high melting and boiling point. Why? Because metal shows very high melting and boiling point just like macromolecules and ionic compounds. So we can expect metals which consist of giant network structure, also it consists of very strong force of attraction. Clear? Okay, so here in metals atoms are tightly packed, but their outer shell electron can separate from the atom easily. So see here, atoms are tightly packed but outer shell electron can move. So this in metal atoms will change to positively charged ion. Okay, in metals atoms are tightly packed but outer shell electron can move freely. So in metals atoms will change to positively charged ions and forms delocalized electron, free moving electrons. And you can see here after this process here a lattice ions with C electrons will be formed. Lattice ion with C of electrons will be formed. You can see here in this figure. Okay, and so here we discuss metals. Atoms are tightly packed, but their outer shell electron can separate from atom very easily and form positively charged atom and negatively charged electron. The force of attraction between positively charged ion and free moving electron, negatively charged free moving electron, this force of attraction is called metallic bond. In metals, there is a positively charged atom and negatively charged electron. The force of attraction between positively charged atom and negatively charged electron, this force of attraction called metallic bond. Okay, this force of attraction is very strong force. That's why metals need very high energy to break this bond, and metal shows very high melting and boiling point. Clear? Okay, next one we have to discuss here some properties of metals. Here, first one we have to discuss here melting point and boiling point. Okay, see here we discussed before, copper shows 1083, melting point of copper 1083, nickel 1455 degrees Celsius, nickel. So generally metal shows very high melting and boiling point, because metals which consist of very strong force of attraction between positively charged metal ion and free moving electron. Very strong force of attraction. We can say strong electrostatic force of attraction between positively charged metal and negatively charged electron. To break this bond, it needs very high energy. That's why generally metal shows very high melting and boiling point. But there is some exception case, soft metals such as metals in group 1 and group 2. In periodic table, metals which coming in group 1 like sodium, potassium, calcium, magnesium, this type of soft metals showing less melting and boiling point. Okay, also here mercury its melting point minus 39 degrees Celsius. Okay, mercury, it is metal, it is exception case, its melting point very less, minus 39 degrees Celsius. Generally we can say metal, they shows very high melting and boiling point because of very strong force of attraction between positively charged metal and negatively charged electron. Clear? Next one we have to discuss here, metals. Metals are malleable and ductile. Malleable mean, what do you mean by malleable? Malleable mean metal can change to metal sheet. By applying high force, metal can change to metal sheet. That is, metals are malleable. Okay, also metals are ductile. By applying force, metals can change to thin wire, metal wire, copper wire, silver wire. So metal can change to thin wire, that is ductile. Okay, so metals are malleable and ductile. You can see here the structure of metal. It consists of layer-like structure. Metals which consist of layers. These layers can slide each other. That's why metals are malleable and ductile. Metals which consist of layers, these layers can slide each other. That's why metals are malleable and ductile. Okay, next property here, metals are good conductor of electricity and heat. Metals are good conductor of electricity and heat. Metals which consist of delocalized electron. metals which consist of free moving electrons or delocalized electron. It helps to conduct electricity and heat. Okay, silver is best conductor. Silver is best conductor after silver copper. Okay, silver is the best conductor. After that, copper is good conductor of electricity. But instead of silver, copper widely used to conduct electricity, or copper wire used to conduct electricity instead of silver, because copper is cheap compared to silver. Copper is less expensive compared to silver. Okay, so here these are the different properties of metals. Metals, they shows very high melting and boiling point because metallic bond, it is very strong force. It need very high energy to break this bond, but mercury is exception case. Okay, metals are malleable and ductile because metals consist of layers. These layers can slide each other. That's why metals are malleable and ductile. Metals are good conductor of electricity because metals which consist of free moving electrons, this free moving electrons helps to pass electricity and heat. Silver is the best conductor of electricity. Next to silver, copper. Okay, so these are the things we have to discuss in this video. We discussed here macromolecules, graphite, diamond, silicon oxide. After that, we discussed metallic bonding, different properties of metals. Okay, so you can just review this video. Okay, so thank you for watching this channel. And you can see here past paper question related to this video. You can check playlist and you can see different questions related to this video, different past paper question related to this video. Okay, thank you.